So let's see if you swear. All right. Where'd my menu go?
Why are you recording this?
Because some people asked to. Okay.
Like, are you gonna put it on Google Plus?
Can you? So we're talking about osmosis here. That's the big topic today. And osmosis is the movement of what?
Water.
Movement of water.
Damn, I hella knew that.
Okay. So let's say I'm looking at this first thing right here. So let's say I take, this is my classy beaker. Inside there, I've got a little bag. You can draw whatever you want, or you can just pay attention. It's up to you. I'm also recording this so I can put it online. I can also take a screenshot of it. So whatever makes your little heart happy. So this is the solution. This is the cell. Okay. Inside both of these, just for the sake of this, I'm going to draw some water molecules. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what we're talking about here is the amount of stuff that's going to be in here. So in this, we're talking about tonicity and the amount of solute. And so we're going to draw these little things right here. If you see that purple thing right there, that's talking about solute. Okay? All these little blue drops,
That's water.
they're water. Okay? So on here, let's say that I've got this cell. And I've got sugar that's inside of this cell. And on here, I've got 1, 2, 3, 4 of these have sugar that's bound to it. On here, I've got 1, 2, 3, 4, 5, 8 of them have it. Okay? If I count this, all right, so let's say I look at the cell. All right? Of this cell right here, how many water molecules do I have that are bound?
12.
In the cell.
Oh, 4.
Okay. So I have 4 that are bound. How many water molecules, so I'm going to put free H2O, do I have that are free inside of the cell? 6. All right. In the solution.
In the solution, you have
How many do I have that are bound?
9 bound, right?
8.
8 bound. No. You have 6 on one side.
I have 5 on one side.
You have 6 on the other side.
There's 8 bound.
Bro. Count again.
Oh, yeah, you're right.
Okay. I have 8. And then number of free water molecules, I have 2. Okay. And so what we're talking about here is the amount of solute that's on each side. Hey guys, cut the talking in the back, please. The amount of solute that's on each side, and we had some fancy terms for that. So in the cell, does that have less solute or more solute compared to the solution?
Less.
Okay, the cell has less. So we learned a term that meant less solute.
Oh,
Hypotonic. So that cell is Tonic. All right, and that solution, would that be hypertonic? Okay, and so we said water always moves from high free water to low free water. If I look in the cell, we said the cell had 6 free water molecules. The solution had 2 free water molecules. So which one has more free water molecules? Okay, you're telling me the cell does. So which way would water move?
from the cell to the solution.
From the cell to the solution. Water should move out. And I'll tell you right now, in osmosis, I'll do it in a different color so it stands out somehow. Water always
What's that one? Tell me about water.
moves from
Something like I drip on your knee, like
Water by
hypotonic to
I don't know. I only listen to Christian music, you know.
okay, hypotonic to hypertonic. Okay. Okay. Anyways, so water always moves from hypotonic to hypertonic. So let's look at a different one. Let's say I've got this right here. Let's say I've got a cell inside of there, and I'm talking about glucose. Let's say on the inside, it's a 0.2 molar glucose solution. Let's say on the outside, it's a 0.6 molar glucose solution. So that outside, would the outside be hypotonic or hypertonic? Hyper. Inside would be hypotonic. And we said water always moves from what to what? Water always moves from hypo to hyper. So would water move into the cell or out of the cell? So in this one, this is hypo, outside hyper, so it's going to move out. Okay. Another one that we could talk about. Let's say, since you guys kind of brought it up earlier. Let's say I've got a fish tank. Let's say I go scuba diving in Monterey, and I've had a fish tank at home. It's a freshwater fish tank. There's some stuff in that freshwater fish tank. I've got to have some stuff in there. But I go get a fish from Monterey. When I got that fish, what kind of a fish is it as far as water-wise? Saltwater. So let's say... Okay, so it's a saltwater goldfish. And if I look at the molarity of these things, all right, I'll draw some water molecules so this is easier to understand. In here, let's say I've got 1, 2, 3, 4, 5. Out here I've got 1, 2, 3, 4, 5. Okay? Solute-wise, we were talking about it. One of them is bound on the outside. On the inside of this, I've got 2, 3, 4 that are bound. Okay? So we said this right here is fresh. This right here is salt. Okay? If I'm looking at this, the inside of this fish has 4 solute molecules for every 5 water molecules. The fresh water has 1 solute molecule for every 5 water molecules. So what would the fish be? Would it be hypertonic, hypotonic, isotonic? Hypertonic. The fish would be hypertonic. And that means the fresh water would be what? Hypotonic. And we said water always moves from what to what? Hypo to hyper, meaning if I took a saltwater fish and put it in a freshwater fish tank, what's going to happen is that free water is going to move to the inside of the fish, and it would make that fish's cells swell up to the point where those cells could actually lyse and the fish could die. Okay? The exact opposite could happen if I put a freshwater fish in salt water.
Does it hurt them?
It would kill it.
How long does it hurt?
I don't know. My guess is like an hour. Okay.
Fish can't feel things?
Yes, they can. A fish has a nervous system. Okay.
Okay, everybody shut up.
All right. Next thing. Let's say I've got this right here. Okay. And what I've got, this beautiful roadway. Okay. Let's say winter happened in icy areas. So let's say you're in the north. Okay, Iceland. Do you know what they put on the roads? Salt. So it stops that ice from freezing on there. But come spring, do you know what the sides of the roads look like? All this stuff right here is dead.
Like grimy and stuff.
It's all grimy, and all the plants that are right on the side of the road are dead. It has something to do with osmosis. Okay? Because what you did, so let's say it all looks like that. So all this, like all the green stuff is still there, but right along the side of the road is all like that. And the reason why is because you have your leaf. So let's say, whoop, 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 whoop. You've got your leaf. Inside of that leaf, let's say, for every 3 water molecules, one of them is bound. Outside of your leaf, for every 3 water molecules, 2 of them are bound. Okay? 2 of them are bound because we put salt around there. So now the outside of this leaf or this plant that's right next to the road, what word could you just use to describe the outside of the plant or outside of the leaf, the roads? Hypo or hyper? Hypertonic. Okay, and the inside of the leaf is hypotonic, meaning all those plants that are right on the side of the road, we dehydrate them. Okay, you literally suck the water out of them. Okay, one last one that we took.
What would it look like if it was isotonic?
If it were isotonic, that would be like I bought a fish from a fish tank or from a store. Like I go to the pet store right here, and I go to the pet store, I buy that fish, they put it in a bag of water. That fish is totally fine because that means it's even. So that would mean like...
But does that mean that each of them are bound?
That would mean like I have 2 that are bound on the inside, 2 that are bound on the outside. It balances.
To balance.
Yep.
And that's iso?
Yep. All right. Last one. Okay. Our last one that we're going to draw right here.
Oh my god, that's why you put salt on the smoothie.
It's got a mustache. Okay. What does your grandma tell you to do with snails?
You put salt on it to kill them.
Put salt on them to kill them. Let's say here's my snail's environment. Okay? Inside of this snail, I've got some water. Let's say there's 5. Let's say in the environment there's water. 4, 5. All right, inside, 2 of these may be bound to stuff. Outside, if I put pure salt on it, there's no free water anywhere. So what word can you use to describe the environment? Hyper. Inside of the snail? Hypo, meaning what way does water move?
From out of the
By adding salt onto that snail, you literally suck any water that's in that snail out of it. Because it's pulling out the water, and that's the water and the air outside of it.
Do they suffer?
They literally die.
But is it like a quick death? No, they suffer already. Well, like if you get shot, you could die quickly.
Yesterday, we took these things and we soaked them in pure water, and they got really, really, really fat.
That looks disgusting.
Okay, they're eggs that we dissolved the shell with vinegar. So yesterday we soaked them in pure water. I don't know if I have any more over here. I think they're all...
No, babe, don't do it.
Oh my god.
This one's still in vinegar, but it gets the point across. Let me get rid of this vinegar real quick.
Oh, it smells. I don't kill them. They just.
I just for my neck. It literally hurts all the time, like the middle.
So, all of these eggs were like this. Okay? All of these eggs were like this. And, oh yeah, I can stop recording. I don't know how to stop. Stop.
Say stop.